right, hi everyone. Once again, I am screencasting the lesson with no students in the room, just so that you have a lesson for Friday while I am out. So your warm-up, there were 3 problems, but 2 of them required trig substitution. So you're just doing this first problem in your warm-up. You can ignore problems 2 and 3 in the solutions if you look at the PDF later on. So this problem, I want you to think carefully about it. Notice that the degree of the top is bigger. See if you can remember what you have to do to approach an integral like that. Go ahead and pause the video, work for a few minutes, and then come back once you have a solution. Okay, so just a reminder that when the degree of the top is bigger, that implies you're going to divide. We're going to use some long division. Once you do your long division, you end up with this lovely thing right here. Get rid of that. Okay. So you do your long division, you end up with this. So you get a quotient of x minus 1 and a remainder of 2x plus 1. I went ahead and factored the denominator. And now once you've got this beautiful factored denominator, it should remind you of partial fractions. So you do a little partial fraction decomposition. And once you're done, you get this answer of 1/2 x squared minus x plus ln absolute x plus 2 plus ln absolute x minus 1 plus c. All right, let's get into the lesson. So today we're doing section 13.3a, which is we're going to learn how to calculate arc length and curvature. So I don't know if you remember this or not, but last year when we did chapter 10 in our old book, we learned a formula for arc length when we were introduced to function parametrically. So the arc length, this is our old function from a to b. The arc length was the square root of x prime squared plus y prime squared, or in other words, it was kind of like the magnitude of the speed. We used it also for distance traveled. It's the same formula. So, the integral of the speed, I should say. So our arc length formula in 3 dimensions is exactly the same, just adding on a 3rd dimension. So this is the one that you're going to need to know and need to know well. So arc length from a to b is the integral from a to b of the square root of x prime squared plus y prime squared plus z prime squared, as long as your function is defined parametrically. All right, so we're going to go ahead and find the arc length of the curve given by r of t equals 1 t squared t cubed from 0 to 2. The first thing that you're going to want to find is r prime, because remember that the formula uses x prime, y prime, and z prime. So r prime would be 0, 2t, 3t squared. Then I have this worked out, so I'm just going to show you the answer. So I'm hoping that you've already paused, worked it out, and come back to it. So if you haven't paused now, work it out. Okay. So our setup, so this is the integral from 0 to 2, because we're going from 0 to 2, of the square root of 0 squared plus 2t squared, which gives you 4t squared, plus 3t squared, which gives you 9t to the 4th. So once you do that, how on earth do you evaluate this integral? So I've given you a kind of a little hint here. You need to factor out the t. Now, how do we evaluate the integral? This is a u substitution question. So if you got stuck, pause it again, see if you can work it out. Remember u substitution, and then unpause and check your answer. Okay, so let's say we've done our u substitution, and we've cleaned up our integral, rewritten it. Don't forget that since this is a definite integral, you have to change your limits to your new u values, right? Remember, u is usually the guts, right? And then you take the derivative, so our du 18t dt. So divide by t, or 18, so you get 1/18 du equals t dt. That's what this is equal to. So you end up with 1/18 times the integral from 4 to 40 of root u du. And then it's an easy integral to evaluate. So you end up with 1/27 times 80 root 10 minus 8. And that is good enough for me. All right, that's all we're going to do on arc length. We're moving on to curvature because there's a lot of different stuff for curvature. Curvature really is the measure of basically the curviness of the curve. It's the book describes it as how quickly a function changes direction. I just like to think of it as how sharp the curve is bending at that point. It's a lot like concavity. So the bigger the number, the more bendy the function is at that point. And the smaller the number for curvature, the more kind of linear looking the function is at that point. It's not curving very much. All right, so curvature is calculated by finding the rate of change of the tangent vector with respect to the arc length. So you end up, when you simplify it out, you end up getting two different formulas. When I first started teaching, I was always using this formula right here. So in the next couple slides, I do have problems worked out using this formula, but I'm also today, just for the video, I'm going to work out using this formula because we found second semester that this one really is actually a bit faster and a little bit easier to use. So I used to do magnitude of t prime over r prime. Now I do magnitude of the cross product of r prime and r double prime divided by the magnitude of r prime cubed. Seems harder, but it's actually really not bad. So magnitude of r prime cross r double prime over r prime cubed gives us the curvature. So let's do this one. So for this first one, I actually have it worked out both ways. So see if you can find the curvature. You can use either method you want. Go ahead and pause the video and see if you can figure this out. All right, so I'm going to show you the way that I like first, and then I'll show you the other way too, just so you can see the difference. So to do it using the cross product formula, you find r prime, which is 2t negative t squared, and r double prime, which is 0, 2, negative 2t. And by the way, if you're doing it at a number, like at t equals 1, you can go ahead and do the cross product with the numbers. You don't have to do it with the variables first and then plug in. You can plug in the numbers right away, and it makes the cross product super easy. So if you're doing it with numbers, you can go ahead and find those numbers right away and do your cross product then. So there's our cross product, negative 244. Remember that the formula, it's the magnitude of this cross product divided by the magnitude of r prime cubed. So you do this. So we find the magnitude of this cross product, so the magnitude of the cross product, so you have 4 plus 16 plus 16 divided by the magnitude of r prime cubed. All right, so you do this over this, and then it's just numbers, and when you're done, you end up with 2 9s. Now, doing it the other way, using the other formula, so again, we still find r prime, find the magnitude of r prime. Same thing, you can find the magnitude at 1. All right, there's our t of t, which is r prime over the magnitude of r prime. You got to find, so t prime of t, isn't that fun? And then you plug, once you find your t prime of t, you plug in a 1. So t prime of t, that's why this formula gets to be kind of a bear, because finding t prime requires you to do the derivative of 2 over t squared plus 2 and the derivative of 2t over t squared plus 2 and the derivative of negative t squared over t squared plus 2. So you end up with a whole bunch of quotient rule, which gets a little complicated, a little tricky. You can think of it as this whole vector, the whole vector over t squared plus 2, and do it kind of as one big quotient rule, one big one, which is what I've done here. So think of it as derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So you kind of do one big quotient rule and then clean it up. So then you can plug in your 1 and you've got your t prime. All right. Magnitude of t prime is just finding the magnitude. So you've got your magnitude of r prime, you've got your magnitude of t prime, and you just divide them. So you end up with 2/3 divided by 3, which is 2 9s. So whichever formula you prefer, I will tell you most students tend to prefer the cross product formula. It's that t prime that just kind of gets a little tricky. Okay. All right, we're going to do the same thing, but you don't get to plug in any numbers. So now I want you to find the curvature, but no numbers to plug in. You can use either formula. I'm going to go ahead and walk you through the one with the cross product, and then I'll show you the other one afterwards. So go ahead and pause, see if you can figure it out. All right, so let's go ahead and do our R prime and our double prime. So our R prime would be 2t and negative t squared. Okay, and our R double prime would be 0, 2, and negative 2t. So now no numbers to plug in. So you're doing the cross product. So R prime cross R double prime. I'm trying to keep it slightly small, but I'm going to use a different color so I can see it better. So 2t negative t squared, 0, 2, negative 2t. All right. So we get negative 4t squared plus 2t squared, so that's negative 2t squared. Okay, and then for our middle, we get negative 4t minus 0, but it's times negative 1, so you get positive 4t. And then for our last one, you get 4 minus 0, so it's just 4. All right, so let's go ahead and find the magnitude. So the magnitude, I think I'm just going to write this out. So our curvature k, so it's the magnitude of the cross product. So it's the square root of 4t to the fourth plus 16t squared plus 16 over the magnitude of r prime cubed. So r prime cubed, so you get 4 plus 4t squared plus t to the fourth. And this whole thing is being cubed. Technically, that's good enough. That gives you the curvature at any value t. I do want you to just take a close look at this for a moment because there's something kind of fun you can do here. So on top, if you pull out a root 4, which is 2, on top you get t to the fourth plus 4t squared plus 4. On the bottom, remember that since we're cubing this, we could think of this as the guts times the root of the guts. Just writing it in descending order. And then if you notice, we have some fun with canceling. So these guys are gone, and you're left with a much nicer answer of 2 over t to the fourth plus 4t squared, plus 4, which also I think factors into t squared plus 2 quantity squared if you wanted to do that as well. All right, so that's that. If you use the other formula, so there's your r prime, there's your magnitude of r prime. Let's see, there's your t of t, so r prime over its magnitude. Your t prime of t uses that fun quotient rule again. And the magnitude of t prime of t, that's where life gets really, really fun. So be careful when you're doing the magnitude of t prime of t. It gets a little fun. Okay, so got that, clean it up. It cleans up beautifully though. And then once you divide, oh, whoops, it should just be t, not once. T, there. All right, so once you divide your magnitude of t prime over your magnitude of r prime, it actually cleans up into 2 over t squared plus 2 squared, which is what we found in the first one too. It's just that it's so much more algebraic effort to do the second formula. So I really do recommend the cross product way, but just know that I don't think your homework cares which way you do it, but it might. So just know the other way is available. All right, one last thing I'm just going to mention. There's another formula for curvature. There's a lot of different formulas for curvature. So if your function by some chance isn't given in parametric form, say your function is given in regular function notation, so some function y equals f of x, then you can find the curvature by doing the magnitude of y double prime over 1 plus y prime squared to the 3 halves. This is not a formula that I would think you'd have to memorize. I don't think I ask it. I'll check. I got to make sure that Normandale doesn't make you memorize it. If they do, then you're going to have to memorize it, but I don't think they do. All right. So, and by the way, there's this thing called the radius of curvature, which is just 1 over k. And what does that mean? I'm going to show you in the next example what the radius of curvature is. And it's actually kind of neat. So the circle that passes through this point that where you're finding the curvature has, if you do a radius of 1 over the curvature, you get this circle that kind of ends up being kind of tangent to your curve. It looks kind of nifty. So find the curvature of the parabola given by y equals x minus 1/4 x squared at x equals 2. Then find the radius and sketch the circle. So, I should pause. I'm pausing. If you want to try to use your formula and solve this problem, take a moment, pause, solve. All right, and we're back. So, y prime is just 1 minus 1/2 x. Y double prime is just -1/2. So plugging into your formula, so you get 1/2 over 1 plus 1 minus 1/2 x quantity squared, all raised to the 3 halves. So just a reminder, so it's the magnitude of y double prime over 1 plus y prime squared to the 3 halves. So the magnitude of -1/2 is +1/2. Think of it as kind of like an absolute value or distance from origin. So the magnitude of the number -1/2 is +1/2. You can think of it as the square root of -1/2 squared. Anyway, so you get that, and then 1 over your y prime squared all to the 3 halves. If you plug in, if we want the curvature at the point 2, 1, then you got to plug in a 2 for x, and if you plug in a 2 for x, you just get a k value of 1/2. All right, which means the radius of curvature is 2. So if we look at the graph, I drew a graph, I didn't draw it, I graphed it. So anyway, a graph of our curve. So this right here, this big bow, that's the actual curve. This point right here, that point, that's the point that we're talking about. It's the point 2, 1 on the curve. So the curvature is the number 1/2, which isn't very big. It's kind of a slightly shallow, it's not super shallow, it's slightly kind of a mild curve there. So if we go down from there to a radius of 2, so look at the scale, so 1, 2, this becomes the center of what's called the circle of curvature, which ends up being this circle with the same curvature as our curve at that point that we're finding the curvature. So kind of fun. I don't think you get tested on this at all. I don't think it's in your homework, but it's just kind of nice little knowledge to have. So radius of curvature is 2, and it's the inverse, the reciprocal of the curvature. That's it, guys. Pretty short lesson. Happy Friday. So go ahead and work together. Get started on your homework, finding arc length and finding curvature. And I will see you Monday. Have a good weekend.